right? Which will be the y value, and this length here would be the adjacent, right? But today we also want to define tangent using the sine and cosine functions. So tangent of theta is also, not only is it equal to opposite over adjacent, but it's also equal to sine of theta over cosine of theta. So that will help us, all of this will help us come up with a way to sketch the graph. Things to watch out for when we graph this thing is that since we're defining a function based on the ratio of two other functions, watch out for divide by zero. Meaning that when the cosine of theta is zero, then the tangent of theta is going to be undefined, because we can't have, no matter what we have for the sine of theta, we can't have the denominator go to zero, because we can't divide by zero. That's one of the fundamental rules of mathematics. So knowing these things and having this table of values, you see here my thetas are in degrees, this table at the top for cosine and sine. We're going to try to sketch a graph for the tangent of theta, okay? And so we're still going to have, I'm going to put it in radians, but we know that pi over 4, for example, is equivalent to how many degrees? You should know that that's 45 degrees, right, for pi over 4. And I'll do negative pi over 4 here also. That would make this pi over 2, and this one will be 3 pi over 4, and this one will be just plain pi. Okay? So, for the angle, when theta is 0 degrees, right? Then we have the cosine of theta, and that's not my chart, but if theta was 0, the cosine of 0, I'm sorry, cosine of 0 is what? Is 1. And when theta is 0, the sine of 0 is what? Is 0. Okay? So if we say that tangent of theta is sine over cosine, then that would mean tangent of 0 is equal to sine of 0. Oh, did I just write that wrong? Sine of 0 over the cosine of 0, which would give us 0 divided by 1. Is this allowed in mathematics? The answer is yes, it is allowed. It is allowed. So the answer to 0 divided by 1 is 0. So we have our first point here on the graph, which is going to be there at the origin when the angle theta is 0, right? But for pi over 4, aka 45 degrees, right? We have cosine of 45 degrees equals root 2 over 2, and the sine of 45 degrees is root 2 over 2. So, if tangent is sine of theta over cosine of theta, then we have tangent of 45 degrees is going to be root 2 over 2 divided by root 2 over 2, which gives us 1. So when we're at pi over 4, we're going to go up to 1. Right? So I'll do one more. I'll do tangent of 60. And so for that one, we'll just look at the table up here for cosine and sine values and make the fraction. So we see cosine of 60 will be a half, and sine will be 0.87. So 0.87 in the numerator, 0.5 in the denominator, 0.87. We've got 1.74. Okay, so we've got even for pi over 6, which would be approximately maybe there, right? It's increasing even more. We would be up here. So what we have is a graph that's sort of looking like this so far, right? And if we looked at negative sign values, we would see a reflection about the x and y, and we would get something that looks like this. But the problem with the divide by zero arises when we try to do tangent of pi over 2. All right? Tangent of, for all, sakes, it could be 90 degrees. Tangent of 90, or tangent of pi over 2. Because what happens is tangent of pi over 2, so that would be the sine of 90 over the cosine of 90, right? And we said the cosine, the values up here for the pi over 2 are x is 0 and y is 1. So we end up having 1 divided by 0. So there's a vertical asymptote here. And at all multiples of pi over 2. So at negative pi over 2, there will be another asymptote, vertical asymptote, negative. Negative pi over 2 is more negative than negative pi over 4. So what we have is at 0 and at pi, we have these repeating graphs that sort of look like x to the third, but it's not x to the third. This is tangent of theta, and it would be repeating and with asymptotes, vertical asymptotes at pi over 2 and all multiples of pi over 2. Thank you for watching.